Here we have the fundamental counting principle. If there are m ways that one event can occur and n ways that another event can occur, then there are m times n ways that both events can occur. So for example, if we go back to that topic of stages, if we have stage 1 and if we have stage 2, if we have m ways in which stage 1 can occur, and if we have n ways in which stage 2 can occur, to get all possible possibilities, we would just multiply them together and have m times n outcomes. So let's apply this with a couple of examples here. So example 1, it says, a man has 4 pairs of pants, 6 shirts, and 8 pairs of socks, and 3 pairs of shoes. Ignoring the fact that some of the combinations may look ridiculous, and how many ways can he get dressed? Here I'm going to begin creating my placeholders, and then I'm going to start filling in the blanks. For this problem, you can see that I have 4 stages. The first one are the pair of pants, the second one are the shirts, the third one are the pairs of socks, and then the last one, the fourth one, are the pairs of shoes. So for pants, I see that I have 4 choices here. For shirts, I see that I have 6 choices. For socks, we can see that we have 8 choices. And finally, for shoes, we can see that we have 3 choices. And now to get how many ways this man can get dressed, we just multiply all of these together, 4 times 6 times 8 times 3, and we can input this in a calculator. And here we get a total of 576 different ways. Let's take a look at another example. So for example 2, a school gives awards in 5 subjects to a class of 7 students, but no one is allowed to win more than 1 award. How many outcomes are possible? And here, since I have 5 subjects, I'm going to have 5 placeholders. You can think of those as my stages, so to speak. And this problem does have a different flavor to the stages. These aren't necessarily stages, so to speak, but we can still use the fundamental counting principle here. So we have a total of 7 students, right? And no one is allowed to win more than 1 award. So for subject number 1, we have a total of 7 students being capable of winning that award. But once we choose this one person to win subject 1 award, then there's only going to be 6 remaining students capable of winning subject 2. And then the same thing goes for subject 3. Once we have someone that won subject 1 award and someone that won subject 2 award, we should only have 5 people remaining to pick up subject 3. And then we should have 4 people remaining being able to capture subject 4 award. And then for subject 5, we would only have 3 people remaining. And now to calculate how many outcomes are possible, we can multiply all of these numbers together. So 7 times 6 times 5 times 4 times 3, and I get a total of 2,520 possible outcomes. Now try to do the next set of problems, and when we come back, we'll talk about factorials.